Welcome to Ask and Learn.
Welcome to the problem number 31.62. This is chapter 31, alternating current. In this question, we are given a LCR circuit and all the components are connected in series with an AC source. And the source terminal has VRMS equals to 60 volt and has a variable frequency omega. And the inductance is equals to 1.8 Henry, capacitance is equals to zero point 0.9 microfarad, and resistance is equals to 300 ohm. So we have in this question A, B, C, and D part of this question. In D part, we will have resistance changing to 30 ohm and 3 ohm. So we will take care of this R1, R2 later. So first, let's find out the answers of A and B and C part. So first, finding out the A part. So we need to find out the resonance frequency, which is equals to 1 over root 100 of LC. So we have omega 1 over root 100 LC. So putting the value of the L and C, so this comes out to be 786 radian per second. Now we're going to the part B. So let's find out the impedance first. So Z is equals to, so putting all these values here, and we know that XC is equals to 1 over omega C and XL is equals to omega L. So at resonance frequency at omega equals to omega naught, so we can find out the value of these values. So at this value, we know that XC is equals to XL. So therefore, Z equals to R. So we have which is equals to 300 ohm. So at resonance frequency, we have XC is equals to XL. Now going to the finding out IRMS value. So we know that IRMS equals to VRMS over impedance. So we have 60 volt over 300. So this gives us 0.2 ampere current. So this is the answer of A and B part. Now we go to the C part now. So we have I equals to 1 over half of IRMS. So which is equals to VRMS over Z, which is equals to VRMS over under root of R square plus XC minus XL square. So this gives us R square plus XC minus XL whole square equals to 4 VRMS square over IRMS square. So this is our equation, and we can find out the omega, and we know that XC is equals to 1 over omega C and XL equals to omega L. So putting all this, so we can find a quadratic equation, and using this we have found that omega square square 3.24. Putting all these values here, so we have plus omega square minus 4.27 into 10 raised to power 6 plus 1.23 into 10 raised to power 12 equals to 0. So this is our equation, and we can solve this equation to find out the omega square. So omega square comes out to be 8.9 into 10 raised to power 5 radian square per second square. So omega comes out to be 943 radian per second. This is one value, and the another one value is omega square equals to 4.28 into 10 raised to power 4.28 into 10 raised to power 5 radian square per second square. So this gives us omega equals to 654 radian per second. So these are the two possible values. So now we go to the D part. So for first we have R equals to 300 ohm. So therefore our IRMS becomes zero point 0.2, and the difference in the frequency is omega 1 minus omega 2, which is these values. So let's take some omega 1. Let's take this is omega 1 and this is omega 2. So this comes out to be 289 radian per second. For second part, we have R equals to 30 ohm, which is equals to the R1 value, using this value here. So using this, we have IRMS equals to 2 ampere. So this gives us omega 1 minus omega 2 magnitude equals to 28 radian per second. Now we go to the third part of D part. So we have R equals to 3 ohm. So our IRMS becomes 20 ampere. So the difference between omega 1 and omega 2 is equals to 2.88 radian per second. So that's all for this question. Thank you for watching the video.